All right, cool. So if you guys want, first of all, I have this Colab notebook, which is just a Jupyter notebook, right? You guys have seen this before, but you're welcome to join it here, and I can share it through the chat, which now I don't know how to find it through. Sorry, my bar got all changed when I shared my screen. Okay, so thank you. There's the Colab thing. So you guys can join this. Just know that you should have editing permissions too. So you can edit things. Try not to delete anything. So, you know, while we're doing it. But this way you can kind of run things parts, or if I ask you guys to code parts, you can. All right. So NumPy. So NumPy is a package, a library, right, that kind of extends off of Python. So we've been using a lot of Python. In fact, we've been using probably a lot of Pandas, right? And so we can actually use NumPy as well. And NumPy is actually kind of interesting because we've been using it in the background. Pandas is actually built on top of NumPy. So a lot of the stuff that we're going to see is actually very similar to how Pandas operates. And there's a reason why we actually use NumPy, but we'll talk about it in a second. So this is how you import it. We usually import it as NP. Oh, and for the record, I've heard a couple people call it NumPy, like not NumPy, but NumP. I personally call it NumPy. It makes more sense to me because it's num in Python. So anyway, but as you might think, number, it's a number package. It's a mathematical package. It's got a lot of functionality to it, but one big thing that we use on it is arrays. And so arrays, you can really think, are very, very similar to list. Okay, so we talked about list in what's in Python and stuff like that, where we can put in a list. So let me ask you guys, if we're making a list in Python, so we have like, you know, let's just say x equals in that list, what kind of things can we put in the list? And just go ahead and shout it out.
Number, character.
Numbers, characters, so like s like that.
Even like dictionaries.
Yeah, if you wanted to put a full dictionary in there, for example, let's say we do like a to 1, right? So we can put a whole lot of different things into list. Okay, in fact, and they all don't have to be the different type. They don't have to be all the same type, right? So lists are very flexible in that way. So if I now print out x, you actually see all those parts in there, right? Cool. And if you guys remember, for a list, how can I get the first element? What number would I put?
0.
X0.
0, right? Cool. So we get the very first element. If I want the first element, or I should say the second element, it'll give me 1 like this. If I want multiple elements, do you guys remember what I do?
Use colon.
Yeah, so it goes 0, 2, and then it doesn't give me the last one. So if I wanted to go from 0 in the first element, I have to put a 2 here. Okay. We can also do some really kind of cool, fun things. For example, -1, as you guys might remember, gives me the last element, counts backwards. You can also do things like you can count by 2s. So for example, if I want everything but count by 2, so that means the very first one, and then the first, skip the next one, go to the next. You can actually see I get number 1, and then I get this element here. So just to make things a little easier, just so we can reference it. Right. You can see I go 1, 3, 5. Okay, that's pretty useful. And I can also count backwards, -2. So again, some Python stuff. And NumPy, when we use an array, kind of looks similar to how we do this, what is called slicing in Python. It looks similar, but it acts a little different sometimes. And we'll talk about what those reasons are. So let's look what a NumPy array looks like. So you'll see here, I've made this my array, just a variable, right? And then np.array. Since we just talked about, what's it called? Object-oriented programming, you can remember that NP is basically an object, right? It's a library. And we're saying we're going to use that function called array. And array has a few other ways you can do some stuff. But the main thing we do is we pass in an array-like object, okay? And that's actually what the documentation actually calls it. It's an array-like, meaning that it doesn't have to be an array or it doesn't have to be a list. It can be something that's like it, basically something you can kind of count through. So you can see here, I passed in a list 1, 2, 3, 4. And so when I run this, you can actually see my array is 1, 2, 3, 4. And you'll notice that it looks a little bit different from then what we saw in a Python list. It actually has the word array here. And in fact, if I do type, you can actually see that it has a NumPy ND array. N stands for like number of dimensions, and then D stands for the dimension array. So basically, this is a special kind of thing. It's not a list. For example, if I went back to here and said, what is this thing? Well, this is just a list. Okay, so they're similar, but they're different. And so you can see, like I kind of mentioned a little bit, you can use multiple things to make an array. So in this case, I use a range, which is actually an object. If you guys remember, if I do range in Python 3, which is what you guys all should be using, you'll see that it gives me this weird object thing. And in fact, if I do a type, you'll see it's a range, it's not just a list. So I can actually pass in a range here, which in this case actually goes from 0 all the way through 9, 10 objects, np.array here. I can also use a tuple, which is similar to a list, but it's immutable. Okay. And then I also, in this case, I use pandas, which I don't, oh yeah, I did import it. Okay. I made a, with pandas, I made a series here. That's how I normally would make a series if I wanted to do it from scratch, but you could also take a data frame and get just one series, and you can pass it into here to NumPy array to make an array. And kind of fun fact about a series actually is a NumPy array in the background. So it actually turns out everything you can do with a NumPy array, you can actually do the same exact thing with a series. Okay. So again, like I said, Pandas is using NumPy in the background, in the back end. Cool. So any questions on this so far? All right. So you can see it's very similar to a list, right? But obviously, like when I print it out like this, it shows me as like, looks like a list. But you'll notice a little different here is that there isn't like those little ones, or sorry, ones, there's little commas when I print it out. So just kind of like be aware that it's similar, and it's meant to look very similar to a list, but it acts differently. Okay. So this gives us to a little bit more like, well, what's the difference? What's going on? And the big thing for NumPy is that you can do a lot of cool, like not cool, but like you can do a lot of really efficient math. So it's made for efficiency. And the curriculum talks about this a little bit, but if you're really curious about it, you can do a little Google searching. And basically what comes down to is that, if you don't know this already, who's heard of C, C++ as a programming language? Just give me a thumbs up if you've heard it before. Okay, cool. So C, C++ is basically a, what's it called? Is a different language, right? And it's actually a very efficient language, but it relies on a lot of like knowing what memory spaces are, where to move everything. So it can be kind of difficult to navigate through. So Python actually is built on top of C, C++, and, or I should say C. And NumPy basically drops into C and does a lot of those efficiency things. So you don't have to think about them. But just know, you'll hear me usually say something called vectorization. Vectorization is a really powerful tool in Pandas, and therefore, well, it's powerful in NumPy, and Pandas uses NumPy. So it has this vectorization into it. Okay. We'll see kind of like this difference and stuff. So for this list, for example, I have this list 0. If I do this list right here and I add 4 to it, what happens? Anyone got a guess before I run it?
Error.
Error. Okay, let's check. And we do have an error. So what happened? Why did we get an error? It says type error. Can only concatenate, basically add on to the list. Can't just do a list. So basically this plus is saying, hey, I want to add on to that list. But in this case, that's not an actual list. You can only add integers, right? So I can, however, add a list to a list. And what happens when I add a list to a list? Kind of gives a hint right here, concatenate, right? So it'll make one big list. So add 4 to the end of that. Okay. So kind of simple, right? It's like, okay, that's cool. Okay, what about multiplication on lists? We already talked about that. So does anyone know? Has anyone tried this out? What happens when you multiply a list? And remember that list 0 is just 1, 2, 3, right? Yeah. Any guesses? Don't be shy. Well, what do you think?
Each item by 3.
Okay, yeah, that's right. That makes sense. If you guys have done like before, like in math, right? You have the parentheses and you like distribute out the 3 or whatever, right? That makes sense, right? Okay, let's run it. That is not what happens, right? And you can actually see instead it just does the list 3 times. Yeah, it's kind of a weird Python thing, which actually makes sense when you think about it a little bit. Is that because we can put whatever we want in a list, right? It might not make sense to multiply 3 within that, whatever that thing is. Like if I put a function inside the list, it wouldn't make sense to multiply the function by 3. So Python instead of just saying, oh, we're not even going to try to do that, say, oh, well, this might be useful. kind of fun fact is that if you have like a string, you can also do the same thing. You can multiply it by a number and go through. Note, however, if I put like a decimal, that's not going to work. It only works for integers, which makes sense if that's what's just repeating. And so does anyone got a guess then when I try to divide a list? So you saw what happens when multiplies. What do you think would happen if we divide it?
Error.
Error, good, yeah. That's a good choice. So error, type error. All right, so I'm kind of showing you like the limitations of what a list is. And of course, we kind of saw we can add lists together. For example, I have list 0 and list 1, 0, 1, 2, 3, 4, 5. And I can see when I print this out, it should be 0, 1, 2, 3, 4, 5, and then I add them together. And I'll actually combine them together when I add them, right? So you can see 0, 1, 2, 3, and then you can see 1, 2, 3, 4. And you can notice that there's those commas in there, right? That's how you kind of can visually quickly tell, oh, that's a normal Python list, not a NumPy array. Okay, so if you were used to like doing matrices and stuff like that, you might realize like, hey, what if I wanted to add these guys together? And sometimes like, oh, for example, that 3, like I think Eric is the one who kind of joined in and said, hey, wouldn't you, it would probably like multiply each part. That would be like, if you're from a math background especially, that's what you want. So that's what NumPy allows. So now we can actually make a NumPy array. In this case, I go from 0, 1, 2, 3. Okay, and I can do all these operations. I can add 3, I can subtract 3, multiply 3, divide by 3, and it will basically distribute out. It'll what's it called? Expand out over the array. So you can see if I add 3, it'll add 3 to each one. If I subtract 3, it'll subtract 3 to each element. Same thing for multiplying, and then even dividing. It works over here. In fact, I could do a floor division, and you can see it does the same thing. Okay. And then when we add 2 arrays for NumPy array, instead of appending them together like we saw with a list, we actually do add up each element in there. Does that make sense? So since I have an array 0, 1, 2, and then, 0, 1, 2, and then 3, 4, 5, the 0 and 3 will be combined, the 1 and 4 will be combined, and the 2 and 5 will be combined, right? So it's kind of like if you ever seen matrices, who's seen matrices before? Kind of thumbs up, raise your hand, yeah. Okay, cool. So if you've seen matrices before, this is exactly what's going on here. And I actually do that, and you can see 0, 1, 2, 3, you can see basically they're added up together. This is the final product, or not product, the final sum, NP array 0 and NP R1. Okay, so one thing I would kind of think, like whenever I think of NumPy arrays, I think of matrices, and that's really what it's used a lot for, is matrix multiplication or vectorization. Okay, so with arrays, we've seen kind of like, okay, this is kind of like a list. We can also make multi-dimensional like arrays and multi-dimensional lists. And what I mean by that, does anyone know like, from looking at this, if I call like, dimension, like what dimension is this array or this list? So it's like
First.
Yeah, good. So it's the first dimension. It's one direction, I like to think of it. So if you're ever done anything like multivariable stuff, usually we say like, oh, a list of numbers are basically a 1D thing. If we had a list by another list, that would be 2D. And if you have a list, and then outward, like depth, you would have 3D. Of course, you can go even further than that. You can go another direction on top of that. Of course, I can't visualize that, but you could do it. Also for the record, because this will come up later on, I'm not gonna like super stress on it. Does anyone know what, if you had just a single number, what dimension that might be?
0.
0, yeah. Okay, so it turns out like 0 is like a point essentially. So kind of fun stuff with math. All right, so I can actually define this array, and a 2D array, and you can actually see, I don't know how well you guys can see this right now, but there's a bracket here and a bracket here. I kind of spaced it out to make it see better, but basically it's essentially a list within a list, right? Or I should say multiple lists within one list. And that's what makes it 2D, right? So if I run this now, you can actually see that NumPy's like, cool, I like it. And you can see there's that list within a list. And then you can go even further, making it 3D. So for example, I'm making an NP array, and you can see there's that square bracket saying, okay, here's a list. And then it's going to be a list of ranges. And remember, ranges are kind of like lists, right? So in this case, it's going from 0, 1, 2, and then what's the next one? 3, 4, 5, and then so on and so forth, and all the way up to 27. So now we actually create this 3-dimensional list. And you can see all these extra little brackets, right? So this is like, if you imagine if I took out this last one, this guy right here is well, I should say, okay, this one's just a list of numbers. This is a list of numbers. And then this whole thing is a list of a list of a list of numbers. So, and you can see how you can go pretty far into that. I could technically keep expanding this out further and further, but I'm not going to do that to your guys' heads right now, because that would be just be a little too much, right? I think 3D is kind of like our maximum right now. But you can see it's like, okay, cool. Like that means you can actually make these three-dimensional objects, especially when we do something like with machine learning. Machine learning relies on all of these algorithms that rely on multiple dimension kind of stuff because you're keeping track of things. In data science in general, when we're doing like features and stuff like that, when you have a bunch of different variables and you're saying, okay, you know, for example, your final project for mod 1 is basically trying to predict the house price based on a bunch of variables, like how many bedrooms does it have? Is it by a waterfront? Is it how many windows it has? I don't know if that's actually one of the variables, but like you can say like all these different variables to factor into a house. Well, if you have 20 different variables, that in a lot of ways is a 20-dimensional problem. You can visualize that in 20 dimensions mathematically. So that's why this is really important. This is really useful to kind of navigate through. Okay, now you can kind of see is that this is really difficult to like, I don't know about you guys, but like when I look at this, I'm like, how many brackets are on there? Like what's going on? So one thing you can do is you can do, NumPy has this thing called shape, and it'll tell you what the shape of that array is, right? Because remember, this is like a big array, right? It's an array of arrays. So that can actually tell me what is that shape of it, essentially the dimension. So in this case, let's look at the 2D array. Our 2D array had 3 numbers, and each of those, I can't talk anymore. Each of these lists, so there's 3 different lists within the big list. And then within that list, there are 3 numbers within it. So it's a 3 by 3 matrix or a 3 by 3 array. Okay, that's usually how you read it. Okay, if I had changed it out instead to, oops, sorry guys, why can't I? Oh, sorry, I was thinking I'm in Jupyter Notebook, and I'm not. Okay, I was trying to edit multiple. If I get rid of this part, it's still a 2D array, but you see it's smaller. In that case, its shape is going to be 3, 2. It's still 3 lists, 3 rows, and 2 columns, or 2 things within those lists. Note, however, if I can't do this. See, you notice this? It gave me this weird stuff because it can't, we can go a little bit more in detail, but these all have to be exactly the same, like the dimension, how many size that is. And that's because NumPy only allows you to keep the same, what's it called? The same type in each of its arrays. So like you can't mix multiple things together. So it's saying, oh, well, this one's, you know, just a number, this is a number, but this is basically only one number. In order for it to handle that, it's like, well, I'm going to keep a list. So note that it's going to give you weird stuff. So be careful with that. But if you ever see like these weird things come out like this, it's usually because you missed a number. So going back to that. And then again, for 3D, you can kind of see there's 3, 3, 3. If I got rid of this guy right here, like this, has anyone got to guess what this shape is? So like you can see this guy, what this 3D shape is, because it's still 3D, right? Take a guess.
Is it 3 by 3 by 2?
Okay, it's 3 by 3 by 2. Anyone else got a guess?
3 by 2 by 2.
Yeah, there's only so many options, right? So good. I think you guys got the right idea, right? It's got to be 2 3s and 1 2 somewhere, right? So if you run this now, you can actually see 2 by 3 by 3. Okay, so yeah, so fun stuff, right? And what's going on here is basically it's going from the outside going in. So you can see it's like, oh, there are, and I should say outside, sorry. Yeah, no, I'm sorry, it is outside. It has these 2 2D lists or arrays. I'm sorry, I keep saying lists. It has 2 2D arrays. There's the first one. Here's the second one, right? And then within those arrays, those 2D arrays, there are 3 there's 3 rows, and then there's 3 elements. So we have a 2 by 3 by 3. Okay. I know, and imagine now if you have like 5 dimensions, it'd just be like crazy, but you can do that kind of stuff. Any questions on this guide? Cool. Thumbs up if you're feeling pretty good. Thumbs down, you're like, sideways. Okay. Yeah.
So if you're going to perform some operation on it, I'm trying to remember from linear algebra, then if you're going to perform an operation on the first element of all the matrices, it would be like 0 plus 18 plus the other number that was there before you took the middle column off, because they're basically stacked on top of each other.
I'm sorry, you said do an operation, but what were you thinking? Like if you had these separately?
Like an addition, if you just add something to, or add the first column together out of all matrices.
Mm-hmm. Yeah, if like
you're stacked on top of each other. So
yeah, you're saying like if they were separate matrices, right? Like if I have one 2D and then another 2D and add them together. Is that what you're saying?
Right.
Yeah. Yeah, you're right. So you would have 18 plus 0, 19 plus 1, 20, or 2 plus 20. Basically, you just match up all those points. So we can
they're just stacked on top of each other.
Yeah. So in case you guys are wondering, just to kind of visualize this a little bit. So if I say like A equals this. No, well, that's not going to work because I don't have commas. But if I could put commas in there and I make this my array here. So I can slice it, but let's see if I do. This is a little bit further out, but like if I do, what did we call it? R3D. I have that array right there. I can also, so if I call this A, and call this B. And you're gonna see this more in the curriculum too, but I'm just kind of showing you quickly what Josh is saying. So if I do if I print out A, and then I print out B, oops, you can see I have two different arrays now. I have this array, which is a 2D array, and this array. And so if I wanted to instead now, this is what you're saying, Josh, right? If you add them together.
Right, but they're all part of the same array, like looking at it, since that's just how it is, how it's assigned. But
oh, okay. You're saying that, yeah, this is like one big array, but in this case, kind of split up into two parts. So if you added them together, yeah, if you had added them up together, you'll see basically it's just that 0 plus 18, 1 plus 19, 2 plus 20, and you can see that part right there. Cool. Yeah, again, like some matrix operations and stuff like that. So yeah, it can get kind of complicated as you get like higher and higher dimensions because you're trying to figure out what matches what. Okay, cool. Any other questions, you guys, before we move on to the next part? All right. So yeah. So this stuff, I honestly think it just takes some practice. Definitely go through the curriculum. The curriculum goes through much more detail than what I can give you guys in a short amount of time. But we can start using some built-in functions to make arrays. So for example, and a lot of times we'll need an array with all zeros or all ones. We can do that. So in this case, NumPy has a built-in function called zeros. And all you got to do is give it shape, saying how many rows, how many columns, how many depth, basically. So you can see this will print out an array of zeros. So you can see there are three 2D arrays. So here's the first one, here's the second one, and here's the third one. And then there's 4 columns, 1, 2, 3, 4. And then there's 5 numbers within each of those little arrays. Okay, and so if I can actually do the dot shape, you actually see it's 3, 4, 5. Oops, yeah. Cool.
Can you add a 4th dimension to that? Just
yeah,
so you get to see how it prints out. Yeah.
Sure. Yeah. So first of all, there's the dimension, right? I'll put it something a little more obvious, like 10, right? Oops. You can see a lot going on there. Maybe 10 was too much. Let's do 2. Okay. So you can see right here, there's a whole lot of little brackets in there. And you can see already it's got really big. And if you're wondering how many numbers this is, it's 3 times 4 times 5 times 2 numbers. So what's that? 12, 60, 120 zeros in here. That's why it's printing out super big. But yeah, you totally could do this. Make it a little smaller just for fun. See? So again, lots of brackets. Basically, it's just 3-dimensional. And of course, you can add in as many as you want. But it's pretty big pretty quickly. Yeah, Usually you won't print out these kind of things because it's just ridiculous. All right, but anyway, that's how you get zeros. There's also something called ones, where you can basically, if anyone can guess, it's going to fill it out with ones. Okay, so same exact idea. You can see all those ones in there, same dimension, or in this case, 3, 4, 5, that's the shape. There's also something called full, where basically you'll fill out that array. So like whatever you want. So if you wanted to put zeros, it's like, oh, I don't want zeros, I want like 27, or I want to put pi in there. For example, I think the curriculum shows putting pi, but if I run this now, you can actually see all of them are 27s now. You could also, like I said, NumPy has a built-in thing called pi. Well, it's a number. So all of these are now pi in there. Cool. And I think there's a few other ones. I'm going to get this wrong. I'm assuming this is Euler's number. Yeah. So Euler's number is in there too, or Euler if you're Italian or something. Okay. You can also, which is kind of cool, you can also make a range. So you can say, you can use the full to make a range like this. Which is cool. Only problem is like, I actually wouldn't use it this way because I mean, you can't do this. Like the curriculum actually says, oh, you can try doing full with this range, but then it won't work with multiple dimensions. It won't broadcast that out, unfortunately. It might make more sense to, you could also do the same exact thing with NP array, but then do just range of 5. Same thing. So cool. All right. Any questions on that? I'm just showing you a few useful functions, and the curriculum shows you those too. Okay. Cool. All right. So slicing and dicing. So I kind of showed you this a little bit, but basically my key point is that if you remember when we take in Python, when we do like a list and we'd use like our brackets to say, oh, get the 0th element, get the first element, things like that. NumPy doesn't work in that same exact way. So sometimes it looks, you might get kind of, I honestly do this, is I'll mix up what my Python looks like and what NumPy is. And you can get some really in-depth of how you can slice these different arrays and stuff like that. So my suggestion is if you ever need to do this, probably look it up, test it, double check it. If you're curious about learning more about it, the curriculum doesn't go full detail into everything. To be honest, you just don't need it for a lot of the lessons that we're doing right now. But if you're wondering, SciPy, which is what it's related to NumPy, has good documentation on all these different ways to slice, and you see these really complicated things. But I'll show you at least some of the stuff right now. So I have this, this is kind of cool. I can use basically to create a random integer, use random integers to create arrays. So you can see right here, the low is 0, the high is 10, meaning that it'll start at 0 and then it'll go at the highest is 10, but -1 that, right? And I can tell its dimension. So in this case, I made it a 5 by 8. I could have easily also put in like, multiple dimensions like that, or I could have made it just 1 dimension. So you can see just 1 dimension, but I wanted to do 2 dimensions. So, okay. So, oh, excuse me. All right, I can take this part and we can actually start slicing around. So this guy right here, this is going to give me the first row. So normally this would give me like the first element, which kind of makes sense here, right? You're like, okay, give me the first element. And remember, it's an array of arrays. So the first element is an array. It's that row, right? Same thing, I get the last row. I can get this last array, okay? And then let me just comment this out so we can see that part first. You can see this last one here, and I get my first one here, okay? And I kind of have this part right here. If I want to get multiple rows, I have that like colon notation, 1 through 3. Does anyone got to guess what this will give me? 1 to 3.
The first 2 rows.
First 2 rows, good. And good, you didn't say the 3rd row, right? Because it shouldn't give us the 3rd row. You can see it gave us that first 2 rows. And in fact, if you look at it carefully, it didn't just give us those 2 rows, it gave it in an array format, right? So this now is a new array. It's a new 2-dimensional array. So for example, if I do dot shape on this, oops, you can see it gives me a dimension of 2 with still 8 numbers in there, because when we have that in there, it has 8 elements in there, but 2 rows. Okay, so that's how you would slice this parts. And of course, you can see, like I made a little general thing here. This is how you can get different parts of the array. I'm not going to go into full detail on this part because there's so many ways you can kind of slice and dice all of this like NumPy arrays. And honestly, I feel like if I went into a lot of detail, it would just go over your guys' head and be like, there's too many numbers going on. But in the curriculum, it does go through, I think I wanted to show you guys that. It does go through a bunch of the slicing parts. I think it's under here. So like on this lesson here, getting started, it will actually show you how you can do different slicings and stuff like that. And again, it is not showing you everything about how to slice. So you can see there's good visualization right here. It's not showing you everything on how to slice, but it gives you a good idea of the options you can do. So where is it? Down here. It's like this, for example. So you can see, for example, if you wanted to get like an element from it. So I didn't write it in here, but maybe I will real quickly. If I wanted to get like, I want this element right here, I can do, let's see, it's R0. Oops, 0, 0. Oops, sorry guys. There you go. So you can see I'm getting that element right there. If I wanted that next one, I can do that one. So it's basically, if you kind of remember back like coordinate systems and stuff like that, I'm getting the 0th row and then, well, okay, I guess the first row, right, starting with 0, and then the second column. That's what's going on right here. Okay, so if I do, I could also do -1 and -1. Have you got any idea what number that would give me?
6.
6? Oh, it's 3.
Oops.
Got it here. Yeah, it's okay. Yeah, so the very last one, right? The last row and the last column. I don't know if you can see it or something. That's okay. But if I wanted to get 6, I could actually do -2, -1. So I get the second to last row.
That's what I meant.
Yeah, good. Dave was just looking in the future. That was the problem. All right, cool. So anyway, that is NumPy. There is a whole lot to NumPy, but that's just a good touch on it and stuff like that. And again, NumPy really is built, or sorry, Pandas is built on top of NumPy, and that's what's going on with a lot of the stuff that's going through. We're not going to talk about it right now, but in Mod 2 later on, we'll talk about different operations you can do in something called vectorization. There's also, I kind of mentioned a little bit that NumPy kind of gets into the weeds of like how the C code works on Python. And so the curriculum talks about this and actually shows you can time the operations to do the same exact stuff. And you'll find that NumPy is usually much quicker. And it's partly because it's doing this thing called vectorization, which again, we can talk more about and stuff like that, but I'm not gonna bore you with a bunch of like memory spaces and stuff like that because you don't need it right now.